Good morning, everyone. The paper I will present today is Internal Control Evaluation, a computational model of the review process. Professor says it's an easy paper, but for me, it's not easy. Anyway, the outline could have 5 points. You know, 5 is a great number. We have 5 fingers, so we can hold something very stable. We have 5 toes, so we can work stably and smoothly. So 5 could support an idea or a conclusion very well. So I use the 5 points framework. The first one is background information. The second one is theoretical basis and definition. And methodology, and result, and conclusion. So this cat is exhausted because so many books, so little time. But this cat is smart. Come on, using high tech and automating the work, because Professor always said that. This is a joke. I expect you.
Yeah.
Laugh here.
Where did you find these slides?
Okay, so first background. The research question is, this research examines how auditor expertise works to evaluate internal control. And actually, this study uses a survey, a questionnaire survey for this project to assess how expertise system can help evaluate internal control. So for the background, first of all, the paper explains 3 definitions. Because this paper was published in 1986, so at that time, these definitions were not very familiar for, even though it's scholars. So the first one is artificial intelligence. It's the part of computer science concerned with designing computer system. And the second one is expert system. That means refers to interactive computer application that help a decision maker by simulating some specific knowledge to set up some rules from this specific knowledge. The third one is decision support system. It refers to any interactive computer application that helps a decision maker by providing access to a large data bank or by implementing decision models. So this means new technology makes decision aid system available.
Just in the formal one, you don't think that's a little bit bizarre that saying that artificial intelligence is a part of computer science that's concerned with designing computer systems? Don't you find that strange?
It's from the paper.
I know, but don't you find, hey, just because it's in a paper or because in the internet doesn't mean it's right.
I mean, not everything I find online is true.
That's correct.
It's on Wikipedia, though.
Wikipedia is pretty good, but they also have things that are not right. Because Wikipedia is voluntary opinions.
Okay.
But don't you find that very weird? This is like saying that artificial intelligence is a part of computer science designed to do astronomical computations. Artificial intelligence is a generic field. It's a generic field that composes a set of subfields like machine learning, machine translation, expert systems, and etc., etc. That can be used for designing computer systems. So it's kind of a weird definition, don't you find it?
because it was published in 1986. So actually, the extent of this definition.
Dreyfus published a paper in '64 saying that there are 4 areas of artificial intelligence. What was it? Formula, language, machine gaming, formula generation, language translation, and beating me the 4. 20 years later, I published other papers saying nothing has been really progressed in artificial intelligence. But now, Big Blue defeated the world champion of chess. Google has a pretty decent translator at this moment. The area that doesn't look very good is the area of original formula creation. They haven't done any of that. But there are algorithms developed in computer science that can have a result and backtrack on it, see if it's wrong. Okay, that's the best they have done. And since '64, a 50 area of artificial intelligence developed, which is this area of expert system, which is capturing human knowledge, which recently has been kind of ignored because a lot of rule-based systems became part of other fields. But so Glenn Gray just recently worked with a couple of our PhD students and published a paper looking at the current area of expert system. Charles, if you remember, captured that paper, I think is, I don't know who wrote it with Glenn. Maybe it wasn't Vicky. Have to see, Sophia, she will know. Okay, and see if send it to everyone, the paper. Because what Glenn did, he came back after I published a series of 6 books on artificial intelligence in accounting and audit. And this was, the last book was published in maybe 2003. And so we kind of wondering if the field disappeared. And what we actually found out that a lot of systems all around are rule-based, like expert system, but they don't call themselves expert system anymore because it became part of generic computer practice. If you don't know how something is done, you do decision rules in there out of experts. So you would even be able to call that, for example, a lease accounting system could be called an expert system because they capture the rules of treatment of leases out of, let's say, the FASB, interpreted them and created a set of rules. And for you accounting students here, this is a dissertation that J.P. Crahell did, and which called formalization of accounting standards. And you that understand accounting, you know about the big argument about principle-based accounting versus rule-based accounting. And principle-based accounting European, rule-based accounting more American. And what JP says there, and we said there, is that this is nonsense because most accounting is resolved by computers, and computers cannot deal with principles. They have to have fixed rules. And so what JP applied it only into leases, in accounting for leases. But he showed that there were like 27 consultations to the FASB trying to interpret specifically what the lease standard said. And at the end, the people who decided how you treat leases is a programmer sitting at SAP or a programmer sitting at one of the other ERP makers. And so this whole idea of kind of principle-based thing is nonsense, because company with 10,000 leases or 100,000 leases or contracts will have to have rules to apply to it. And so that basically that you will have to put these rules based in the system, and you don't call that an expert system. But that's what we did originally as an expert system. Another paper that we did here was a dissertation, part of the dissertation of Abdullah's, and basically was creating rules for looking at P-card transactions at Procter & Gamble. And that was we basically interviewed the person that reviewed P-card transactions and created a computer model that represented them. Chow, let's send them also the Abdullah and Denise paper on P-card.
progress in this area. In this paper, the authors link expertise and audit task. They say expertise is some knowledge, including public information and providing information, including some sort of heuristic. So, audit internal accounting control have two objectives. The first one is to satisfy an evaluation whether existing internal controls is reliable and decide which auditing procedures are to be restricted and help clients to improve existing internal control. So this kind of audit from 2004, the SOX section 404 stress this internal control assessment, so it's become more important in this area. So the second is theoretical basis and definition. In this paper, first of all, the authors set up the conceptualization model. The first role is initial reading of data and set up objectives and check the controls and the faults and what kind of faults scenarios are in this comfort in this company. And after that, use specific data search to check control assumptions and some unanswered question. That means for some points whether the controls exist in this in the client's internal control system. So the result of internal control evaluation task consists of 2 points. Figure 1b of the paper shows that the first one is a suggested list of controls for the compliance testing phase, and the second one is a list of control weaknesses. The specific weakness identified are combined with controls to determine sufficiency for each control objectives preceding substantive test. That means if the evaluation says there are some weaknesses, the auditors should do decision to set up substantive test for these weaknesses point. So under this conceptualization and definitions demonstration, the study defines 3 things for this study. The first one is subjects. The subject of this project is from a large auditing firm. It's there's some experienced auditor and also medium management of the firm. The task difficulty in this project is because there's no unique set of controls, normative controls, everybody public accepting. So they avoid the this kind of a benchmark and takes a questionnaire to evaluate internal control. And the task is the project asks these subjects to review and evaluate actual auditing flowchart and work papers to identify weaknesses and recommend compliance tests. So for this, so the methodology is about the decision process. The goal of this project is to, and also for this methodology, it's not a problem solve. The authors of the paper claimed this several times. It's not a problem solve. It's just to help understand the editorial auditor's decision process and validate that understanding, including two phases, discovery and verification. So it's not provide a problem solve, say I can solve this problem in this way. I just provide some understanding about how auditors do decision, the process and validate and verification, verify this understanding. So the first phase is discovery, is to develop a theory of task performance for experts. The second phase is the verification. So for discovery phase, in this stage, the first task is develop a model. This model is description of problem solving steps and some heuristics that represent auditor judgment. So in this paper, there are a lot of definitions, not a little bit confusing. So in the model development stage, the project set up three things. The first one is identify internal control objective. The second is identify controls and faults in accounting system. And the last one is evaluating the system controls. So under these tasks, the paper shows how to get knowledge, how to acquire knowledge. And the paper used University of Minnesota, a professor like Lynn Johnson's work to set up three methods to get knowledge. The first one is observational method. Figure 4 in the paper shows this how the project used the observational method to acquire knowledge. Thinking aloud the protocol to identify problem solving mechanisms. And the audit process includes three stages. The first stage is episodes. It's about the big picture. The second is views or frames of reference. And the last one is a problem solving process. So for episodes, it's a macro analysis. It helps the auditors to get a big picture about the firm. It included six stages about decide on the likely inherent risk category of client and choose suitable audit approach. And also, after that, decide whether significant controls existed. And also choose boundary of compliance test, choose controls of compliance test, and evaluation and conclusions. So this stage helps auditors get a big picture about the clients. The second is views or frames of references identified by auditor protocol. is detailed. It's about processing and about how to figure out the segregation of duties and electronic data processing factor and the adequacy of working paper. So in this stage, decision operators provide the links between individual knowledge states at the macro level. So it's detailed. After so this is the first knowledge acquisition. It's observation. The second method to acquire knowledge is descriptive methods. It's about transforming knowledge into an explicit representation, often in the form of heuristic or rules. For example, it says when you face this kind of problems, you should take what kind of rules, what kind of objectives or method to cover this problem. The third method to acquire knowledge is intuitive methods. It includes interacting with literature and literature. It's from some others' research or their experience to describe the basis for his or her own knowledge. So these three kinds of methods to help get knowledge, get the expert system basis. So after that, the project shows the knowledge representation structure. It also says this structure is not for universal task. It's just only for rule-based representation to similar situations. That means I do not want to use this structure to solve any problem. I just say if these situations happen, you can use this method this rule to solve the problem. After that, the paper shows the model implementation and tooling. He used the Glean modeling tool. And the inference engine include a partition, search, and checking. This is the first phase, discovery phase, this discovery state. The second one is the verification this model. The verification of this model. They did two tests to verify the existing model. The first test is the quality of model processes of Q usage. It tests the sufficiency or adequacy of model outcomes. Some figures demonstrated in the paper. The second test is the subjects, these experienced auditors are asked to list two things. The first one is recommendations for specific controls to be compliance tested. The second one is weaknesses identified from the system description. Use these two questions to verify the existing model. The paper also illustrates the quality of model process method. One is top-down from the specific task to how to do the decision process. The second one is bottom-up, and the third one is line of reasoning and search strategy.
Okay, let me just kind of give you a notation thing. When you are doing modeling, you typically will do validation and verification. Validation means what? You think this process is exponential. You look if your computer code or your Excel sheet is really exponential. If what you coded corresponds to what it wanted to be. That's validation. Verification. Now you have formulated this idea that the process is exponential. Now you have to see if in real life it's exponential. That's verification. Okay, so when you're building models, there is always these two things. First, did you manage to do what you wanted to do? Second part of it, what you wanted to do, is it representative or not? One more question as far as you stop me for a second. What is an inference engine? It's a part of the expert system that deals with rules. Yes, you have rule A, rule B, rule C. The configurator of a digital equipment computer had 10,000 rules. How do you deal with these rules? How do you implement these rules? How do you bring them together? So creates inference out of the rules. That's what the inference, that's the core of any expert system. Okay? You have knowledge acquisition, you have databases, and then you have an inference engine that picks up the rules based on the data that you find and generates inference, generates outcomes. So that's the inference engine. I will remember, and next time I'll show you an architecture for an expert system so you can understand what they are doing.
So the second test is take a peer review to test the adequacy of model outcome. After this test, after the verification stage, the result shows first, hypothesis generation by the model are quite different from the primary arbiters. Second, process identified consistency. That means that the model works well. First of all, figure 4 shows the armed cognitive process arbiter decision was scored of the process in use. This figure is not easy to understand, to read it, right? But it shows that the conclusion is consistency. And figure 4 shows that whenever the model is outside the range of percentage found in the 4 export protocol average. And also the Q usage for the order is consistency. They also employ the line of reasoning. And the last result is the adequacy of model outcomes. First, model is different modular, different from modular. Second, no substantial difference between primary arbiters and the model. Third, 3 arbiters are judged by experts. So this paper is one of the earlier exploration of how to computation of some arbiter activities or some accounting activities. The conclusion included 2 points. The first one is dynamic theory. Mental procedures can be modeled. You can model this kind of mental procedures. The second is point predictions occur with exact predictions of how a given task will be done under variations in the knowledge base, and alternative task or conditions can be hypothesized. It's not an easy paper. So far after the paper, I believe Professor has a it's very great to say automation can help solve all of the problems. And because my project in the sandbox is about automation, the internal control effectiveness. So I would like to also say something about what I want to do. It's different from the paper, but it's also another computation. I will use 6 steps to do this project. The first one is analyze the firm's value chain and REA, the resource, event, and agent, to determine which business process to be continuous control monitoring.
REA is McCarthy. Do you all know REA? REA is kind of one of the basic axioms, and they now call it design theory and etc. And that's basically Bill McCarthy's work, that Graham Grau, Guido Goetz, a whole group of people that work on this REA stuff. Okay, and if you've never seen it, probably it's worthwhile reading the Accounting Review, maybe in the 70s, of Bill McCarthy, for you to know what that thing is. Because it's important part of literature, was one of the most quoted papers ever in the systems literature. So, Chow, see if you can find Bill McCarthy's paper, the first, the published Accounting Review, and send it to everyone, okay?
After that, choosing best model for this continuous control monitoring. And in this table, I would like to propose the use of 6 Sigma to set up some dynamic criteria for this control flow. Yeah, maybe it's beyond this topic. After that, developing related system architecture and developing guideline and managing exceptional exceptions and tuning, analyzing exceptional exceptions and tuning this system and making be a circle. And actually use this circle to accumulate business intelligence and help the internal auditors to improve operation effectiveness and efficiency. That's all. Thank you.
I love to see this. I have seen this paper discussed many times, and I love to see Edward permeating it with our notation, exceptions, and that kind of things. It just kind of surprises me how much things changed over the years.